Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on August 13th, 2025, which was about 5 days ago. The big hook is a unified, open-source virtual reality teleoperation stack that delivers real-time bimanual control, synchronized dataset recording, and policy training across very different robots. The paper is titled BEAVR, Bimanual, Multi-Embodiment, Accessible, Virtual Reality Teleoperation System for Robots. And, as we will see later, the engineering choices make the results quite compelling. In short, it standardizes data through the LeRobot format, achieves low latency control up to 90 Hz, and trains strong Visuomotor policies end-to-end. Building on that, the tweets frame robot teleoperation as the killer app for virtual reality, with a reply endorsing open-source frameworks that evolve continuously. Engagement looks decent, roughly 100 likes and a thread of replies. Also, the authors shared a GitHub repo. You'll find an open-source VR teleoperation stack with Python/ROS modules, a Unity VR app submodule, configs and calibration files, Docker setups, and docs. There are scripts for teleop and data collection, multi-robot URDF assets, simulation support for Mujoko/Isaac, plus a quick start via Conda. Alright, this figure sketches the end-to-end data flow at 90 Hz. Start by looking at the full pipeline box. Input data from a virtual reality headset feeds hand key points into the detector, which estimates joint landmarks. Next, the operator stage builds a stable hand frame, performs coordinate transforms from virtual reality to robot space, and solves inverse kinematics for targets. Finally, the interface stage streams those commands to the robot, closing the loop for real-time, bimanual teleoperation and synchronized logging. Next, the diagram shows the hand key points that drive the detector at 90 Hz. Focus on the full graphics area. Each hand displays 24 tracked landmarks labeled from wrist to metacarpal, palm, proximal, intermediate, distal, and tip. The small red, green, and blue axes indicate local X right, Y up, and Z back, which define a stable hand frame used for coordinate transforms. Left and right hands appear from the back view, providing 6 degrees of freedom wrist poses plus fingertip targets for inverse kinematics. Okay, this table compares expert teleoperation across 3 tasks, showing success rate on the left and median completion time on the right. Focus on the full table to see 4 systems side by side. For Flip Cube, all methods succeed, while completion time varies, with OpenTeach fastest and our system close behind. For Pour, only OpenTeach and our system succeed, though our time is longer. For Pick and Place, OpenTeach and our system succeed, with our system finishing fastest. Moving to the results, this table summarizes 6 manipulation tasks with success rates and average completion times. Focus on the full table to see clear trends. Flip Cube and Pick and Place reach 100% success, finishing in about 16 and 12 seconds respectively. Lantern and Pour both hit 80%, but Pour is much slower at roughly 85 seconds, reflecting liquid handling difficulty. Tape Task and Stack Blocks land at 60 and 70%, with moderate times around 18 to 26 seconds. Now, this table reports real-time control fidelity across configurations. Focus on the full table. Achieved frequency stays near targets, roughly 30 Hz for single and bimanual runs, and about 90 to 100 Hz for the fastest setup. Building on that, the jitter column shows stability, under 1 millisecond for the arm, and under a quarter millisecond for the leap hand. Together, these numbers confirm smooth scaling to more effectors without degrading timing. Building on those timing results, 2 takeaways stand out. First, the system makes low-cost virtual reality teleoperation genuinely real-time, with roughly 10 millisecond one-way latency and stable 90 Hz control. Second, the unified LeRobot dataset export bridges teleop to policy training, powering strong ACT and DiffusionPolicy results. Thanks for listening. I am Alex, signing off.